Welcome to another segment of my physics videos, and we continue with our current electricity, but this time we are focusing on resistors in series. Remember, there are two types of resistor arrangement like I mentioned in my previous video. Resistors can either be arranged in series or they could actually be arranged in parallel. So in this video, I'm going to focus on resistors arranged in series. But what exactly do we mean when we say they are arranged in series? Well, when resistors are arranged in series, it simply means that they are in the same line. There are no branches that you have. For example, if you look at resistor 1, resistor 2, resistor 3, these have actually been arranged in what we are calling as being in series because there are no branches, and therefore we say they are arranged in series. Well, if we say, the three resistors are connected to that, you remember that's an ammeter, and the total voltage from the source, let me just call it as being V total. How do you get the total resistance in the circuit? Now, sometimes I want you to take note, the total resistance sometimes is called the effective resistance, or, we can say the equivalent resistance. That's what they can say. Well, for you to get resistors, total resistors in series, what we do is that for the total resistor RT, that's for total, you just need to add the resistors. That is resistor 1 plus, resistor 2 plus, in this case, resistor 3. So if there are so many resistors, you can keep on adding them. That's what we mean. So if you had so many other resistors, you can just keep on adding them, and that's what I mean by Rn. So that's the way you get your total resistors. Now I want you to take note of a few points that I want to put up, a few tips that I want to give you. For resistors in series, they are potential dividers. So we can simply say they are potential dividers. Remember, PD dividers. What do I mean they are potential dividers? Well, I mean, as the potential difference, as current is passing through each resistor, a potential difference will build up. So there will be a voltage drop there. If you were to connect a voltmeter across this resistor, and you were to connect a voltmeter across this resistor 2, and to connect a resistor across resistor 3. Let me call it V1, let me call that one V2, and let me call this one as being V3. V2 there. So the way it is going to happen is that, the total voltage from the source is actually going to be divided. This total voltage will be divided across each resistor depending on the value of the resistor. Meaning, if you want to get the total voltage from the source, it will be as a result of adding voltage 1 plus voltage 2 plus voltage 3 passing through each of those resistors. That's what we mean when we say they are potential dividers. So they are potential dividers. So let me just do this. Let me just write it on top there. So the tip there that we have there, we can simply say that they are PD potential dividers. So meaning the potential difference from the source is actually divided among the resistors. So to get the total voltage, it's V1 plus V2 plus V3. That's what we mean there. The other concept that you need to remember for resistors in series, that the current is the same through each resistor. So we can say the current is the same through each resistor. So the current will always be the same through each resistor. We mean if at all we have the total current, we know the total current passing through the circuit. It simply means that the current total passing through the circuit will be the same as the current passing through resistor 1, that will be current 1. It will be the same as the current passing through resistor 2, and it will be the same as the current passing through resistor 3. And that's what we mean when we say the current is always the same. So think of it like you pour water in a pipe. The same water that will pass there, if you're pouring maybe a 2 liter, will pass through that, it will pass through that. So the current is the same. What is different is simply, the potential difference depending on the value of the resistance there. And in case you want to basically know how did we come up with that, but what you can do is very simple. Let me just try to give you there. We said their potential divider, so total voltage is equal to V1 plus V2 plus V3. So what I can do, because I know from Ohm's law, remember, we know from Ohm's law that voltage is equal to current times resistance. So we can replace at each of these. Where there's voltage, we replace with current and voltage. So it will be IR is equal to IR again plus again there, IR plus again, IR. That's what we mean. But it doesn't make sense. Remember, this is voltage total. So therefore, I can be putting up a total there. Because that's voltage 1, I can say current 1, resistor 1 there, current 2, resistor 2 there, current 3, resistor 3. But what do you know? You know that the total current is the same as the current passing through resistor 1, the same as through resistor 2 and resistor 3. So those are the same. So I can cancel out the current because they are the same. So I'll cancel all these out because they are the same. So what am I going to remain with? I'll remain with R total is equal to here. I'll remain with R1 plus there, R2 plus there, R3. So if you want to find the total resistance in a series circuit, you just need to add them. Now let's try to say, imagine that this was 1 ohms and this was actually 2 ohms, and let's say this was 3 ohms, and they tell me to say find the total resistor. How was it going to be? Well, it simply means my R total, I will just add 1 plus 2 plus 3, which is going to give me 6 ohms. Then that would have been the total resistance. Well, let me demonstrate by looking at a typical question that you're going to see, behind. So there's a typical question that I prepared well in advance coming from, one of, the sample questions. So it says study the circuit diagram below. So they have given us, this is the circuit diagram, and we have got 2 resistors. So I'll label them for simplicity's sake. I'll label them. I'll call 10 as being resistor 1, and I'll call 20 as being resistor 2. You can label them however you want, it doesn't matter. The total voltage from the source is simply 20 volts. So now let's figure out how we can actually go about that. So the question there says find the equivalent resistance. So sometimes in the exam, when they use equivalent resistors, words that they are going to be using, they can simply use words like find the effective resistant. They can also use words like find the combined resistance. That's what they mean. All these, when they use equivalent, effective, combined, they mean you're finding the total. But pay attention with what they are telling you in the question. All right, so the A part there, if we look at the solution there, it says find the equivalent resistance. Of course, the equivalent or the total resistor, there are only 2 resistors, so I'll just say resistor 1 plus resistor 2. So resistor total will be, you just add that is 10 plus 20. So resistor total, that is going to give you 30 ohms. Units are very important in physics. And of course, show your formula there. Then B is saying we find the total current in the circuit. Remember, we can apply Ohm's law, which says that current is equal to voltage over resistance. I'm sure you remember, according to Ohm's law, which we put up in a triangle. If I can just remind you there, we did say voltage is current times resistor. So current is voltage divided by resistor. So now, since this is the total current I want to find, I can say the total current will be the voltage total times, divided by the resistor total. So the current total will be, what is the total voltage they have given us there, which is 12 volts, divided by the total resistance, which we have found there, which is equal to 30 ohms. So what is that going to give us when we divide? So using your calculator, 12 divided by 30, so that is going to give me a 0.4 amps. So meaning that is the current passing through the circuit. In fact, that sometimes they can say, what is the ammeter reading? It simply means the current passing through the total current is 0.4. Now remember what we said, if 0.4 is passing through the ammeter, 0.4 will pass here and 0.4 will pass through the other side. That's what we did talk about for resistors that are arranged in series. Very important that you remember that concept. Let's now move on to the other question there. The C part question there, I'll clean up so that I can create enough space so that you are able to see. The C part there says the current through each. So I want us to find the current through each resistor. So remember, the current passing through each resistor is simply the current is the same. So the current through this one, resistor 1, is 0.4 amps. And the current that is passing through resistor 2 is still the same, 0.4 amps. So you didn't even need to start, wondering. D says the voltage drop across each resistor. So they want you to find the voltage drop across each resistor. Now the voltage drop across each resistor is very simple. What you can do to find the voltage drop across each resistor, you could apply Ohm's law. Voltage is equal to current times resistor. Let me start with resistor 1. It will be the current through resistor 1 and the value of resistor 1. So it will be voltage across resistor 1 will be the current 0.4 times the value of the resistor, which is 10. So it is going to give me 4 volts. That's what we mean. So voltage passing through resistor 1 is 4 volts. What about voltage passing through resistor 2? It will be current 2 times the value of that resistor. So the current is 0.4 and the value of the resistor is 20. When you multiply that on your calculator, it will give you 8 volts. And remember, if you add 4 plus 8, it will give you 12. The total from the source, no wonder we said that for resistors in series, they divide the potential difference. All right, thank you so much. In my next video, before I start looking at resistors in parallel, I'll show you what we call the potential divider rule when you have resistors in series. So it's easy to find, the voltage drop across each of those resistors by using the potential divider rule. Thank you so much. See you in my next video.